So when I'm taking the derivative of, let's take this function, let me do it in red. If I've got this function right here, if I wanted to graph it, I know it would be, let's say these are by 2's, so that I can fit it at 2, 4, 6, 8. There's the y-intercept. The x-intercept is going to be, I'm not going to have an x-intercept. Nice, easy x-intercept to do. Let me do it the old-fashioned way. I'm going to take half of this and square it. So half of that squared is 16. So I'm going to have to also subtract 16. Since I added 16, I have to subtract 16. Remember this, completing the square?
Yeah.
So it's x minus 4 squared minus 7. That helped me find, that's the quickest and easiest way, as much as you might hate it, to find my h and my k. So positive 4 comma negative 7. Positive 4, which is here. 1, 2, 3, negative 7 would be right there. So there's my vertex. Okay? So I'm not going to worry so much about my x-intercepts, because I don't think that they're nice numbers. They don't look to be nice numbers. Well, negative 1. No, that's not right. Negative. No, it's not. They're not nice numbers. They're somewhere in between here. I could actually find it pretty easily by just taking the square root of that and adding 4 to it. So they're 4 plus or minus the square root of 7. So they're right here, somewhere here, and somewhere over here. And if I go up over it, I want symmetry, right? Because this is my vertex. So symmetry tells me there's going to be another point right here. That point is, well, this was 4. Then I've got to go another 4. So that point is 8 comma, and that up there is 9. So the 8 comma 9 is another point on my graph. Just to give me another point, there's my graph. All right, so here's what derivatives are all about. If I wanted to know the derivative, let's even take it at this point, right? If I wanted to know what the derivative at that point is, what that's saying is, what if I could turn this, if I could zoom in on this, let me zoom in on that right there. I'll make it down here, I'll make it bigger. Is that a line or a curve?
Curve.
It's a curve, but if I zoom in more and more and more and more, what's it going to look like? The closer I get, it's going to be a line. That's the idea behind a derivative. What I'm doing with the derivative is I'm taking this point right there, but I'm finding the rise over run. The closer I get to this, I'm finding the rise over the run. The rise over the run. I'm getting closer and closer and closer until it looks like a line, not a curve, and that's called the tangent line. So this line right here, if I could draw the line in, which I'm not good with this utensil here, but if I could draw that line in, that's called the tangent line. The slope of the tangent line at this point, 8, 9, is the derivative of this function. That's the idea behind derivative. The derivative takes any graph. Let's take any graph. What if I have this crazy graph right here? The derivative of this graph is going to give me a formula that will give me the slope at any point.
Oh, okay, that would make sense. Like why it does at like x equals 3.
Right. So when you do that old-fashioned formula, which was f of x minus h minus or plus h minus f of x all over h, and what were we doing? As h goes to 0, we're finding the limit of this as h goes to 0. This is the rise. Remember from slope, and this is the run. And what are we making the run get closer and closer to? 0. So in other words, we're zooming in on this point right there, and we're getting closer and closer and closer until it doesn't look like a curve anymore. It looks like just a line. And that's the idea of slope. It's turning, derivative. It's turning every graph into the simplest function that we know, which is a line, so that we can determine what's so valuable about a line. The slope is the rate of change. So I know what's happening, how this green graph at that exact point, or let's go back, at this exact point, 8, 9, at that exact point, how quickly is it changing? Meaning, as I go right,
Yeah.
how much is it going up? And that's what it's giving me. The derivative is giving me the slope. So that's the concept of slope and the reason behind what we're doing.